So thank you so much for joining us for another edition of Renew Education. This is our April edition, and we're bringing the topics on energy storage and grid infrastructure. Our first speaker is already here, and please permit me to tell you a little bit about our first speaker, and then he's going to take the floor. Um, Let me pull up the presentation. And please, if you have joined us, please share your name and where you're joining us from on the group chat. Yeah, I mean in the chat box, sorry. Please share your name and where you're joining us from in the chat box. Thank you. I'm Shalom Ivo and I'm joining from the United States. Oh, you're welcome. You're welcome, everybody. You're welcome, Oluwa Nifemi. I hope I got that right. Thank you for joining. Thank you. Thank you for joining, Enak. You're welcome. All right. Our first speaker will be Dr. Peter Owo. And I'll just tell you a little bit because you can see he has a wide range of expertise and experience. But I'm just going to tell you a little bit and then he's going to tell us more about like his journey and then on the topic. So permit me to introduce you to Dr. Peter Samora Owo. He is a seasoned expert in advanced materials and battery anode development, and he's currently serving as a business development manager at Morgan Advanced Materials in, in State College, Pennsylvania. With a strong background in material science and engineering, he bridges high impact research with the commercialization of innovative technologies. He earned his PhD in materials engineering from Rice University, where he focused on nanomaterials and energy storage. His prior roles as a graduate research fellow and research associate at Rice University and Oak Ridge National Laboratory sharpened his expertise in materials design and optimization using methods such as design of experiments and advanced statistical analysis. He has contributed significantly to advancing additive manufacturing techniques, including laser power bed fusion, to fragment micron-sized particles to the nanoscale for improved energy storage performance. His work also includes the development of 3D printed graphene foams and integration of nanomaterials in metal matrix composites. Widely recognized for bridging academic research with industrial application, Dr. Owo remains a key contributor to the advancement of composite materials and nanotechnology, supporting the global shift towards sustainable energy solutions. So please share your warm emojis, reactions in the chat box and just out there. And let's make welcome Dr. Peter for his presentation. Thank you. Dr. Peter, over to you.
Yeah, I was about to unmute myself. So I think you've done a very good job of introducing me. I think you've covered pretty much everything which needs to be covered. So for the people in the audience, I see somebody say they're joining from Uganda. So I am originally from Kenya, came to the US in 2012, did my master's in Alabama. And then, as Shalom mentioned, I did my PhD from Rice University, Material Science and Nanotechnology. So I think for now, the way I would like, the best thing for me to do here would be, Shalom has done a very good job of introducing me. So then I think like what I can do is just kind of like maybe just give you guys some pointers on how you navigate maybe grad school a little bit. And then from there, how do you transition to industrial work? Because research in academics is different from research in industry. So I think that will be valuable information for people in the audience. So first of all, I'll start with the what you call the academic research. So all of us have you go to grad school for the love of science. That's what we normally say, especially if you want to do a PhD, it's for the love of science. Money is just an added advantage. If you end up making money as a PhD, then good for you. But it's mainly for the love of science. So I when I was doing my master's, my idea was to finish my master's and then just go straight into working. And then I met this professor from Ghana who completely changed my life. I was in his office, I was talking to him, he asked me, so what next after your master's? And he was completely from a different department. I told him, I'm planning to go to work. He looked at me and then he's like, young boy, that's one of the worst, terrible idea I've ever had. So me, I'm like, why? Because everybody finishes and then they go for work. By that time, by the way, at that time when I was in the US, Intel was hiring every African with a master's back then. So it was so tempting. Everybody, before somebody is finishing, is telling you, I already have a job with Intel. He was like, that's a terrible idea. Uh, he- uh, he's like, no, you need to go for a PhD. I was like, what? He's like, yes, you need to go and do a PhD. You're still young. You have an opportunity. You're here in the US. Go ahead and do the PhD. Even if you don't like it, you can hang it in your room once you finish. Later you will use it. I was like, okay. So now, the process of applying. So this is a key now when it comes to the process of applying for the people in the audience who are trying to apply. So for the US PhD application is it's a very different process. First of all, the application itself is like a work on its own. So you have to do a very good job of researching the university you want to join. And then once you do that, you have to go and start digging into the professors, specific professor of what you're interested in, and then align your research with what they're saying they are doing. Because in the US, for the PhD, it's the professors who hire, not the grad school. The grad school, their job is just to do the preliminary verification, screening. But then ultimately, it's the professors who hire. So once you do that, you can curate your messages to the professors, email them, their emails are normally available. And, I'll tell you the truth, 99% of them won't reply, but there are some of them who reply. And then, even for those ones who do not reply, do not lose hope, because what happens is if you are really good, because professors are very busy, they are writing grants throughout and then chasing students like Sharon here, do this. So even if you write and then they don't respond, if you really like the school, just go ahead and apply, because ultimately when you pass through the first phase of the grad school screening, when the professors are sitting around and then the names of students are being called that, oh, these are the people who have passed and we are thinking of hiring them. If your name comes up and then that professor suddenly remember, oh, this student emailed me some time back and I really like that profile. And then that professor will kind of like take a keen interest in your application. And that's how you get in. Most of the time it's not about don't give up even if you don't get any response. So then that's what I did when I was at Alabama. Again, as usual, when in the US, we normally have a rule. So you break down your schools based on the ranking. So you look, for example, top 20 schools, you apply maybe to a couple of them. In the middle of the pack, you apply to 3 schools or something like that. And then the last one is normally what we normally call sure. I mean, the surefire, no matter what, you'll get in. So you break in your application, to the top school, the mid school, and the ones which no matter what, you'll be able to get in. Don't make a mistake of applying to top 10 schools. The competition there is so fierce. You're competing with the Chinese, the Indians, and all over the place. It's not that you're from Africa, you cannot compete, but it's a game of numbers. So you want to increase your chances. So that's what I did, did a very good, that. And then I went back to the professor and I asked him, okay, I think I'm ready. And then I told him, so he asked me, so what do you want to start as your PhD? I was very happy. I was like, so since I was in material science, I was like, I want to do study mechanical engineering. He was like, I mean, he's like, you really have a passion for some very stupid idea. Why would you want to start mechanical engineering? I was like, that's a good degree. He's like, no, don't do that. You need to study something which is a niche. Not very many people are studying specific stuff. Uh, that's what you need to study. So that's why I ended up with nanotechnology, because back then it was just picking up. And then, for some people who are in that industry right now, you can see right now it's when it's blowing up. Everybody's kind of like, they are looking for people who have studied that. So that was really great. So again, I ended up at Rice. Go there, again, rule number one, when you get to your grad school, you have to align yourself with some postdoc. So these are the guys who have finished their PhD, but they are still in school just doing research. So they are very, very good source of mentorship to you, because they've gone through the process and they will tell you what to do, what not to do. So you align yourself with there. I was there, I was lucky, met some guys, who really were fantastic mentors. They guided me very well, what not to do, what to do. They tell you the true stuff of uh, how the PhD is, and then what kind of research you're supposed to really focus on. Because most of the time, of course, the professor will give you an idea of what needs to be done, but it's your job to figure out how do you turn that one into some fantastic research. And the way it was explained to me back then, a PhD, somebody explained a PhD in a very simple terms. It's like a PhD is very, not simple. This is how it is. Your professor takes you and think of a forest. Professor will take you and put you in a section of a forest. Your job is to find the tree which nobody has ever found. That's how you graduate as a PhD, because remember, you graduate by introducing new knowledge, quote unquote, which did not exist. So, so then, I did a lot of work there, collaborated a lot. That's very important, because if you work by yourself, sometimes it can be very, very, very challenging. It's in the US, I don't know about other countries. My experience is just the US. For the people in the audience who are currently or did their PhD in the US will attest to this. It's really hard. It does not matter which discipline you are. It's very, very, very demanding. A lot of work. So then after there, you immediately after your year two or something like that, you have to decide: do you want to be in academics long term, or you want to go to industry? So then, because whatever you do after year two will determine how are you going to position yourself. So if you think you're going to be in academics, then you need to align all your research, your connections, your conferences, they have to align in those directions. So there is no way if you want to be in academics and then you attend industrial conferences, they don't help you. If you're in academics, you attend academic conferences. So if, for example, if you are in material science like me, you will attend MRS and all this other stuff. But if you want to go to industry, now you look for industrial conferences, because all industry This is in the US again. They do have their conferences. So that's what you need to attend. Why do you want to attend those ones? It's because that's where you will get your connection to the job market. So in the US, more than 70% of jobs are gotten by referral. So in other words, for example, today, if a couple of you guys apply to my company, and then one of you was referred to somebody I know, I will hire that person before I hire the other person, even though this simply means both of you have the same qualification. So we put too much effort, not effort really, we put too much credit to referral. So even in the US, more than 70% of the jobs are still by referral. But the key thing is, before somebody refer you, he or she must know that you can do the job. If you cannot do the job, there's absolutely no way they're going to refer you. So it's your job to present yourself to those people that you can really do the job. So again, as I mentioned, you really have to decide whether you want to go to academics or you want to go to industry. Then align all your research, align all your whatever you do in those directions. And then so you attend and then for most of the time for again, US case studies. All schools, they have what is called career fairs. So you are supposed to start attending those career fairs in your second year. It's not that you're looking for a job. No, you want to learn how it is done. You want to learn how interviews are done, etc. And then again, for the US, most school, which most graduate students do not know, you're already paying for it. So the Office of Career Department, you can write your resume no matter how bad it is. You take it to them. They will ask you what industry you want to go to, and then they will tailor that resume based on that. And then they can even train you on how to do interview questions. And then if you ask them, I want to go to this industry, say I want to go to civil, they will look into the alumni database. For example, they normally look like maybe last year or a couple of years ago, which people from your department or from the school itself are in that industry. And then they will connect you to those guys. So you want to use those guys as some of your mentors, and then to kind of like learn the industry, etc. So if you are in a US university, please make sure you use those resources. They're there, you're already paying for them. Very important. So then again, finally you end up in industrial research, where now, we do research which makes money. It's no longer about fundamental stuff. It is a bit of fundamental, but mainly we focus more on things which can be able to generate money. So the only difference is, the only big difference in industrial research is very quick. So these are no more than 1 year, maximum couple of years. You must provide an answer. And in industry, most of the time, it's solving customers' problem. So you have to understand what is the problem really. So this, you'll be sitting in front of your potential, whatever, the customers, and then they will tell you, we are having issues with this stuff. So your job as a PhD is to figure out, what's really the problem. And then you have to design experiment based on that. You have to come up with the KPIs, and then you have to do some very thorough DOEs. This is design of experiments, to try and really find out the real problem. And then after that, you solve that problem. Of course, not by yourself. You have a team of guys who are working for you. And most of the time, this is what normally happens with the PhD. Again, I'm biased, so this is on science. It's very rare for you to be able to go to the lab and do all the characterization and all this other stuff. All company, they have what we call technicians. So your job as a PhD is to design the experiment for them to understand. And then they're going to run those experiments. And then your job is to interpret the results in a sense that you can be able to generate money for the company. So that's the main stuff. And then there was another difference between industry and academics In industry, you may be working on 4 or 5 problems at the same time. In academics, you only have one issue. You're only researching on one thing. So that's kind of like the main big difference. So for example, right now I can give you an example. Now that we are doing some stuff to do with green energy. So right now I have in my project, I'm looking at designing anodes for the batteries. So now I'm looking at lithium battery. I'm looking at lithium sulfur. I'm looking at sodium battery. I'm looking at solid state. So you can see all the different types of chemistry, we are looking at them. So because we do not want to just focus on one thing. So now, it's all over, you are supposed to wear many hats in industry. That's the main difference. And you have to be very, 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 very quickly. So that's kind of like a very deep analysis of what the main stuff is and where we are up to now. So now I think I can just answer a bunch of questions if you guys have them. You're muted. Oh, there
Okay.
you are.
Yes. So there's a question from Enoch. He's asking, what is nanotechnology and how does it relate to energy storage?
Ah, that's a fantastic question. I normally like it. That's a fantastic question. So I'm going to explain to you in the term which you can understand what nanotechnology is all about. Imagine, I want to use a reference from in Africa, for instance. What would be what? Oh, yeah, this one everybody will know if you watch the World Cup in South Africa in 2010. So imagine you are in a 60,000 seater stadium. Take an ant, the ones which build stuff in the soil, and then you put it in the middle of the field, and then you go all the way to the top floor of that stadium, and then you're supposed to look at that ant. So that's technically the analogy of nanotechnology. This is this another way to look at it is like this. You are a typical human a single strand of your hair is roughly 100 microns. And nanotechnology is 10 minus 9. So when we talk about nanotechnology, we are talking about something which is roughly 1,000 or maybe 10,000 smaller than your strand of hair. So how does it relate to energy storage? For people who are studying energy storage right now, you've heard about silicon anodes. So silicon, this is just typical sand. Sand. So when you see sand, that is silicon oxide. So when we want to use it for the battery, we have to remove oxygen from silicon. So we break the oxygen, pull it away, and then we remain with silicon. But the problem is oxygen likes silicon too much. So now, once we break it, now when we use silicon as it is, say for example, if I use silicon in the micron range, this is 10 minus 6. So if I use that as a lithium anode, when I put lithium inside there, think of like a balloon. So it will blow up to something like 300%. So now, but if I reduce the size of that silicon to the nanoscale, which is 10 minus 9, so now I can be able to prevent that expansion of that silicon. So that's how nanotechnology relates to battery storage. That is on the silicon. And then when you look on the other side on the carbon stuff, there's something we call carbon nanotubes. So these ones are, think of a strand again of your strand of hair, but now the diameter is less than, it is in the range of 10 minus 9. So that's nano. So that's what we call carbon nanotubes. So now those ones, they are very, very good conductors of electricity. So we can use those ones and then we add them into some of this graphite, blah, blah, and then we end up making anodes. So that's how nanotechnology is playing a major part in battery. But pharmaceutical industry, they've been using nanotechnology for a very long time. Your sunscreen has nanotechnology in it. The particles, those particles, there are some particles there which are nano. That's why when you apply that lotion, those nanoparticle goes in and stay in the pores of your skin. So
Mm.
yes, that's nanotechnology.
And so I do have a follow-up question to that. You
Yeah.
mentioned different types of batteries. So with
Mm-hmm.
your experience, like are there classes of these batteries? I know
Mm-hmm.
most of us are new to this field. So the
Yes.
classes of these batteries and what kind of forms of these batteries can be used for? Is it like small systems, solar system, small system energy development, and then the large scale energy storage systems?
Oh, that's a fantastic question. So currently, uh, the the king of the battery stuff is lithium battery. So it's the one which we have completely optimized. Very good. It's in your phone. It is in your laptop. You've heard about large scale energy storage. You've had
Mhm.
some companies going to Africa try to build some energy storage. All those ones are lithium battery. So the only caveat is most of them cannot hold the charge for more than 4 hours. So currently we are trying to chase for something which could be able to hold energy for more than 4 hours. But right now, the dominant battery with more than 90% of the market share is lithium battery. And the way it is made is very simple. So you have a battery is it's a very simple stuff. So you're just shifting for the people in the here who are chemists. You are just shifting electrons from one side to the other. So you have what we call the anodes, and then you have what we call the cathodes. On the anode side, this is where you have graphite. It's the dominant material right now. And then on the cathode side, this is where you have things like cobalt. Every time you hear about the cobalt in the Congo, it's normally in the cathodes. So you take lithium, you combine it with cobalt, yeah, and then you combine it with manganese or aluminum, and then you make the cathodes. So all you are doing is that you are just shifting electrons from one side to the other. The way I normally like to explain a battery in a simple terms to people is think of two garage, high-rise garage. So you're moving cars from one garage to the other. So those cars are your lithium ions. And then once that is charging, when you are discharging, you're moving them from the other side to this other side. That's it. But remember, in the process of you moving them, some of them will break down, etc., and all this other stuff. So that's when you are kind of like your battery starts to die. And that's why even for your iPhone, again in the US, let me just say your smartphone. And that's why your smartphone, with time, that battery starts to degrade. It's because some of those cars can no longer be able to be moved back. So now you lose your capacity, and then you have to change that phone to a new one, or rather you have to replace your battery with another battery. So that's simply how the battery works. But currently, it's lithium battery. That's the most dominant battery right now.
And can we also use the lithium for grid scale storage systems or it's
Yes.
yeah, okay.
Yes, currently all the grid storage, all the grid contract you're hearing being signed is lithium battery, all of them. But the only difference is the cathode chemistry. Most of
Okay.
them they are using what is called LFP. So this is lithium iron phosphate. They have removed cobalt because of the issues with the Congo cobalts and all these other things going on. So most of it is lithium iron phosphate. But your laptop, your mobile phone will never get rid of cobalt. Forget about it. It's not anytime soon. Otherwise, we do not want to go back to your phone looking like a brick if we want to get rid of cobalt from your phone. So that cobalt will stay there for some time until we find another solution. But all the grid storage you hear right now mostly is lithium battery. There are some people
Mhm.
who are working on vanadium battery. This is what we call flow battery. But that one again, it has a lot of issues. So it's less than 1% market share. And then you also have some high temperature sodium battery, especially I think the Chinese have one. But most 99% right now is just lithium battery.
Okay. Are there other questions? Please drop them in the chat box, and I would ask another one that is a follow-up. Our second speaker joined, but I think maybe there's some internet connections, but I will try to reach out to her to get back on the call. And so the last time we were talking about this, they mentioned statistics and resources that can give, or like companies or agencies that are working with the real statistics on energy storage. Can you share more about that? That is like people, if they want to get to know um, papers or research outputs that tells us exactly what we need to know in the grid scale and utility scale battery storage systems. What resources can people look up to get those information?
That's a very good question. So most of the time, your first source of information, you wanna go into some of these battery makers. So they are the ones who are normally, they put a lot of this information out there. And currently, the biggest battery maker on the planet is CATL. This is a Chinese company. So if
Okay.
you their website, you will find all the information you want. And then you wanna go into the other guys which makes batteries. So you have Panasonic, uh, you have LG Energy Solution, you have SK On, you have a bunch of other Chinese companies. So that is when you want to understand on the high level, because remember for them, when they do some of this information, they normally try to present it to their investors. So majority of their investors are not scientists. So they will present the information in such a way that anybody can be able to understand, right? So that's going to be your first point. So that will simply give you the market, where the market is going. And most of the time, when these guys put out those reports, they will they normally put a one slide where they show what is their market cap, not cap, I mean, what is their market segmentation, and then if if they're nice enough, they will mention other companies there, so that can give you a clear idea of where everything is. So that is just on the industrial side of things. Now, if you want to really focus on the science part of it now, the,
Mm.
the stuff, the things which are now the understanding of all this other stuff. So now this is where you can go to. There are some journals which are specifically for energy storage. So one of them, uh, uh, Nature Nanotechnology, not nanotechnology, Nature Energy. It just focus on stuff to do with energy. Then you have Advanced Energy Material. Then you have uh, this journal from Elsevier, very famous. Something power sources. Very good journal. They started doing it a long time ago. So that's another one if you have access to these journals. And then also for the people who don't have access to this, especially if you're from Africa and all this other stuff, there are a lot of open source journals. So you want to look at those open source journals, and one of them is Nature Communication is open source. Advanced Science have a journal. What's the name of that journal? Science Advances. That is open source. You have this British Royal Society. Royal Society, they also have some journals which are open source. So sometime you'll be lucky to find some of those papers which are open source. And then the best strategy which you can use is, if you do not have a Google Scholar account, even if you have a single paper, you need to create it. And then once you have that account of yours, and then you can go to Google Scholar with that account, and then you can put alerts. So if you are interested in lithium battery, or you are interested in, say, for example, you're studying silicon battery, or you are studying what another example, whatever, lead battery, whatever. So you put those alerts. Now, you can put the frequency of how you want it. So every time, Google will send you a list of all the papers which came out with with your alerts. So now, for all the ones which are open source, they will come as PDF. So your job is just to click on that link, and then it will take you to the PDF of the paper. And then if some of you, most of you, if you are in universities, especially in the US, most universities in the US, they have access to all those journals. So that's not gonna be a trouble for you. You just click on that one, and then it will take you straight to those papers. And then you'll be able to know the science, how the field is moving, blah, blah, blah. But then again, most of the time, you normally have to start from scratch. You have to understand the fundamentals first. Uh, you can never be just go straight and start reading a journal paper if it is not from your industry, because there's a reason why a journal paper is 5, 6 pages, because it is normally written for specific group of people in that field who already understand. So if you go to read a journal paper which is not in your field, you are doing a disservice to yourself. Most of the time, you won't understand the jargons which are there. So you have to understand the basics first. And most of the time, this is not what I normally tell people. The best way for you to get the fundamental of any industry you want to study, go to your library, grab a book start from scratch. It will explain everything from scratch, and then you will understand the fundamentals. And then now when you get hold of that paper, now it will start to make sense. Does that answer your question?
Yes, I've come across some of this outlets like, Nature Energy. They do amazing research, and most of their should I say, the publications are usually very novel. So I really
Yes,
applaud what they do from
yes.
whatever they put out there from Nature Energy.
Yeah, and then it's normally that it's kind of like a rule of thing, a rule of thumb. As a
Yeah.
PhD, I don't know how you guys are doing it, because everybody can adopt whatever works for them best.
Yeah.
But for me, when we were being trained at Rice as PhD students, there was a rule that every week you had to read a paper which you are going to present it to your team members.
Yeah.
So that kind of like really, really help us. But again, if you got whatever school you are in, if you don't have your professor is not telling you to do that, I would suggest you just form a club of a bunch of people, and then you guys just decide, if you are 5 of you, you say, every week you're gonna read just a single paper, and then one person present this week, the other person present the other week. And then we used to dig very deep, and then you'll be even asking yourself, if the paper is in science or is in nature, then you'll be forced to explain to the group, why did science or nature accept this paper? Or why did nature nanotechnology accept this paper? Because for you to get into science or nature, I mean, it has to be an
Yeah.
amazing
It has
work.
to be outstanding.
So that simply means, so most of the time I remember when we were still in grad school, none of us was trying to get those papers, because the other guys will kill you. But I mean, you will have no answer. How can you explain why this paper got into science? But with the time, when you are starting, it's hard. But by the time you are in your fifth year or 6 years, now you absolutely understand. And by the if you read so many papers, it will reach a point whereby when you see a paper, even if it is new, you don't even waste time. You read the abstract,
Yeah.
and then you are like, okay, I know what they're up to. And then you just check the images to
Yeah.
confirm what they are talking about. And then after that, you read the conclusion. Done. If it is so interesting, now you go to the methodology.
Mhm.
So that's what we did it when we were there. So I mean, it is if it is something which you guys I mean you can implement. You just need a bunch of like-minded people like you. Because as a PhD student, that is one thing which is very, very critical. Because by the time you are finishing your PhD, we normally a PhD we there are two skills which you must have before you graduate. One is to find information. You are trained to find information very, very quickly. And then two, you are trained to solve a problem in a very systematic manner. And that's why you see, for example, for the people in the US in the audience, you see majority of these big three consulting companies, they are hiring PhD. It's because they know PhD knows how to solve problems better than even
Yeah,
M.
sure. Yeah, we adopted that methodology. So at
Yeah.
first, when we started in the lab, we felt it was very strenuous to be presenting papers every 2 weeks. But right now, we are getting the curse of it, and my professor makes it a habit. Everyone in the lab presents a paper, and it just
Yeah.
goes around like that. So this semester, I've read 3 papers that are related to my field that are even part of my future work. So really building knowledge on that.
Yes, it's very, very important. It's a very, very good skill for you to have.
Mm. I think there's a question here from Mr. Adetoro. He said that the issue of affordability and safety, especially like from the explosion of lithium ion battery, usage for utility consumption and the rest. He said, how is the academic or like industry going to surmount this challenge?
That's fantastic. If you solve that problem today, you become a billionaire. There's a reason
Mm,
why there's no any battery next to a hospital or close to any human settlement. It's because we've not solved the problem of safety. So a lithium battery has everything which a fire needs.
mm,
Remember, on your cathodes, they are metal oxide. And then when you are shifting those lithium back and forth, there's a lot of resistance. You will generate heat. And once you generate heat, you have oxygen already. And then the electrolyte, it's flammable liquid. So you see, that's why at the end of the day, the thing normally will explode. And that's why if you're flying, they are not going to allow you to put a battery on your checked-in bag. They normally ask you, do you have anything with the lithium in your checked-in bag? Because they know once the fire starts down there in the belly of the plane, they will never be able to get to it. So we've not solved that problem, my friend. So that's why we need as many scientists as possible into this field to try and help us solve that problem. But you see some of, and that's why, for example, especially the cobalt one is the one which is a very, very big problem. So lithium iron phosphate is a little bit safer. And then with some new other chemistry, lithium sulfur, sodium battery, they are still going to have their own issues, but those ones we've not really figured it out yet. We've not figured it out, the explosion issue, my friend. So you are welcome to join the cause.
And then, so I see you've given a career recommendation. So particularly for those that want to, in like remain in the space in energy storage, what other career options should they explore in, and what kind of questions should they look forward to solving in the space?
Oh, there are so many problems, so many problems. There are tons of problems because think about it, right? Your phone, you charge it every day, right?
Mm,
So that's a very big problem right there, you know? So somebody needs to figure out how to solve that one, right? And then when it comes to grid storage, we've only done like less than 2%, right? Big
yeah.
problems. Solve that problem again, right? So there are so many problems which need solving, so many. And you can just focus on whatever area you want. There are tons of problems which need to be solved. But again, if you just the energy storage space is going to be very, very, very big, like extremely big. We are just starting. We are very early. And then there are a ton of chemistry out there. You can focus on sodium, you can focus on solid state, you can focus on lithium sulfur. There are so many research going on out there. So we welcome everybody. The more, the better.
Are there more questions in the chat? I don't think there are questions here, but okay, there's one. And if you want to unmute, please raise your hand. I can also give it to you, Shadrach, if you would want to ask your question directly. Shadrach, would you want to ask the question directly? Feel free to introduce yourself and ask your question directly.
Right, so it's Shadrach from Uganda, and my question is, given Africa's growing e-waste problem and the risk of cadmium accumulation from the nickel cadmium batteries, what practical strategies can really be deployed to prevent the environmental contamination and build sustainable recycling systems?
So Richard, that's a very good question actually. So that's why we say we need everybody, right? So if you dig a little bit deeper into research, you will see there are a bunch of companies which are already working on that space, especially for lithium battery. So cadmium, I'm not an expert in cadmium nickel battery. So I am completely that one. I have no I don't know. I have no solution there. But I don't think that could be one of the business venture. There are a bunch of companies in Africa which are starting to look into this. So if you can take it up out there in Uganda, that would be, it will be appreciated.
Okay, so Adetoro, would you want to ask your question directly too? I see there's another one in the chat box.
Yeah, thank you, Shalom and Doctor. Can you hear me?
Yes.
Yeah, I so much appreciate the didactic method in which Doctor is explaining the Li or lithium-ion battery and its derivatives or varieties. Though I'm also getting or learning one or two knowledge around lithium-ion as an energy expert or a practitioner. So, like, so much appreciate. So, like my dear brother who just mentioned from Uganda, the issue of uh, the issue of how will I say it, disposal, such that we won't go back to where we started from in the issue of sustainability, what issue of concern, because we are looking at, especially in Africa or maybe in the West Africa, the next 10, 20 years when some of the deployed solar system will have their lifespan coming to an end. So how do we go about also sure that we have a safe disposal of all this new technology in terms of lithium and its derivatives? That's just my concern. Do you get my question on my?
Yes, I did. So you're talking about the Solar West, and just like your colleague in Uganda about the US, right? So
Yeah.
the solar. So one of the things which we are because solar panels is just it's silicon. So if the only problem is you have silicon, also you have some very dangerous heavy metal within the whole system. So there are some companies which have started to look into this. If you look at the US, if you look at in Asia, in Africa, I'm not too familiar because again, I come from there, but it's very little presence of even some of the stuff which we are doing. So most of the time, even if you look at most of the time, even when you look at the battery storage and all this stuff, you never see them put Africa. Africa is normally categorized with the rest of the world because the volume is too small. But again, we are installing a lot of solar. But again, Africa, the biggest problem you will have, even for the solar, for instance, most of the solar in Africa, it's kind of like residential solar, which is one guy has a panel, another guy has a panel, another guy has a panel. Recycling that one is a pain because you have to the logistics of it is a big problem. So the only way it makes sense for you to recycle something is if you can be able to make money out of it. This is one of the reasons why you see even plastic is very difficult to recycle. People don't really care because, especially the guys who are making it, because it's much cheaper to make it from a new virgin plastic rather than recycling. Because remember, apart from science, apart from pursuing the science part of it, in industry, anything we do, it has to make an economic sense. If it does not make an economic sense, we won't bother. So, but we know in the next few years, the solar stuff will start to become a problem, and then somebody has to figure out how to do some recycling. And if you look at, for example, even for the lithium, there's something called, if you have time, just go and Google it, it's called black mass. So this is when they are trying to recycle lithium battery. You break it down and then they try to separate. They use some, pyrometallurgy or whatever, some other metallurgical processes to get the stuff out of it. So for the solar, it's going to be the same. So if you think this is something which would be very interesting for you to do, you may start looking into it. And there are a bunch of open source literature out there on how to recycle solar panels. And some of them, if you see, some of them are trying to say, oh, we can redirect this one into the battery, etc., etc. So look into them if this is really something you want to do. And again, I normally kind of like give a cautionary tale to people. If you decide that you're going to dive into something, you must go full. It's not a half, it's not supposed to be like your part-time kind of like thing you're doing your part-time, enjoying yourself. No, you really have to go deeper into that space and say, okay, this is what I'm going to try to solve, and then I'm going to spend all my time trying to fix this problem.
I know you spoke about something which is recycling, and there are tons of questions, even those in the industry, those in academia. There are tons of questions that are being asked within the research of recycling solar panels and batteries. But I see one question here, and I will call Andrew to ask this question directly. If you have a question, you can just also put up your hand, and we would use 10 minutes to take the two more questions. So Andrew.
Thank you, Shalom, for the opportunity. I would like to throw more light on the lithium ion batteries. I know the world is mainly focusing on now the renewable energy sources, mainly solar in Africa, whereby the solar energy potential is much. But then we still have really a great challenge whereby tons and tons of these solar products are being produced. They end up being dumped in Africa. It's like there is no producer responsibility about the product they're producing, because if we have really responsible production and consumption, there we can know that, okay, my end product is ending here, and then I will be responsible on recycling it. So it's like they are trying to promote only the linear economy, not the circular economy. And I say with a nearby time, this may be a problem. Could he please, him as the academics who is trying to do a lot of research on this, try to look at the possible ways of at least trying to promote the circular economy of some of the renewable energy sources.
I think the question is really similar to the previous one. But go ahead, Dr. Peter.
Yeah, so I think the question is very similar to the other, but again, we sometimes we just have to, it has to go back to our government, because most of the time, majority of these companies, they really do not care about Africa. So we are normally kind of like the last place where they will just dump stuff and then they just run away. And then again, because, without mincing any words, is because, this company understand how the African system works. So you have a bunch of the guys who are in charge of the environment, and then they take those guys, put them in their pockets, and then that's it. So they will just, for example, right now, in some for example, if you go to Europe right now, all these companies who are sending battery there, they have rules which they're supposed to adhere to, you know. You have to you have to commit this amount of money for this thing to be recycled. But in Africa, I mean, nothing like that is happening. And it's the same thing, for example, right now, if you see in a lot of these forums, most people are thinking uh, majority of these IC cars, this is internal combustion engine cars, most of them will be dumped in Africa when all these developed countries move into electric vehicles, because I mean they'll be so cheap, and then most of these companies they need to find a way of selling these cars. So most people are already thinking that most of them they will run and dump these cars into Africa. So the question is going to be, if African government does not really put some specific rules on how to prevent this, I mean, we are always going to be in trouble. For example, I mean, if you can see some, I could be wrong, but Africa is the one place whereby, you know, you have, for example, you have rules that no, a car not more than 8 years is supposed to be shipped to us. But I can tell you for free, if you go to Africa, there are cars there with more than 15 years, which were shipped there. So this is so your question is, it's mainly on policy. So it has, you know, it's not really the science part of it. It's just policy, and this policy has to be really taken up with some government policymakers. But otherwise, if they don't do that, we are just going to be a dumping place. I mean, I'm sure you've seen some of these videos whereby they show a lot of e-waste going to Ghana. I mean, some companies specifically, they just go and dump it there, and then they just put it into their whatever those dump sites, and then you see people touching those things with their hands, you know, holding mercury, cadmium. That's cancer, you know. And then so you see some people just burning them in the open. That's cancer, but you know, so this is just policy. We have to fix our policy. That's what I would say as Africans. Otherwise, if we don't do that, it's just going to be continue to be trouble for us.
Yeah. And I mean, there are certain things that I know some of us, we discussed this, especially I know Michael, we discussed a lot about African systems, African policies, and it is true that if we don't put those policies in place, it will be difficult for us to control what technologies are being sent to us, and even how those technologies are going to affect us in the near future. I do see a final question here, which is from Hasmia. Hasmia, are you there? Do you want to unmute and ask your question directly? But I can, Hasmia, are you there? Okay, I can ask this one directly. So she's curious because you know, a lot of solutions are out there, solar panels, batteries. You've already mentioned about lithium ion batteries, and she's asking, like, from your experience being a scientist in this space, what are like your recommendations on solar panels, the best ones, and batteries and charge controllers? I assume she's trying to put up a solar home solution for herself.
That's a good one. So most of the time, to be honest with you, in Africa, you will just end up with the Chinese solutions. So those are the only ones you will end up with. So now it's just going to be for you to really think about, you know, what is gonna be the best solution for you. And then you just have to ask the people who have already installed and then get their opinion, because in Africa right now, most of your stuff is just Chinese. So I cannot recommend something from even from here in the US. You won't be able to get it, or rather, it is too expensive. So, for example, you know Tesla has power walls and all this other stuff.
Yeah.
That's the best system. The only thing in Africa is the cost of that thing is enough for you to build a one single bedroom. one single bedroom house. So you're better off sticking with those Chinese products. But the key is you need to ask the people who have already installed it and then get their opinion, maybe ask 10 guys. The problem most of us we normally do when we want to do something, we just install, you know. The best idea is normally talk to the people who have already installed and then different types of system. And then since you are scientists, you are not supposed to do things like somebody who has not gone to school. And then you do your own metrics and then you decide based on my system, based on the people I talk to, I think system A meets my specification because you have to specify what do you need it for. I need 2 hours, I need 4 hours, I need because again, you know, I'm assuming all of you guys here you are scientists, so you need to start approaching your problem in such manner, not just like everybody else. So you do that, you first of all you come up with a specification of your own system of what you need. And then after that, you start talking to, I'm sure wherever you live, you will find a bunch of people who have installed different type of system, and then you will get their opinion because now you are talking to the guys who are already having it, so they know the shortcoming of that stuff, and then they will redirect you into the best system. That will be my suggestion. There's no way I can advise you from here and tell you, or go buy this and this from this company. That won't be that will be malpractice on my side.
Right. I totally agree with you that the cost of solar panels, especially the ones produced in the US, is it's really the price is
Very
really
expensive.
amazing. Yes. You wanted to say something?
No.
Okay, okay. I do have this final hand. Please permit us. He's a researcher in Europe, and just a question from him, Michael.
Yeah, it's nice, nice. Thank you very much, Shalom, for this wonderful program. Yes, I wanted to ask a question about Africa's potential in terms of manufacturing these renewable technologies. And we have almost all the critical minerals from silicon, cobalt, lithium. So why is it that we are not able to really manufacture some of these technologies in Africa? Or is it that we don't have research institutions to also help in the process of funding? What is the main challenge? Or we don't have the electricity capacity, let's say the electricity to really industrialize. That's why we don't have these companies investing. So what is the main challenge in Africa for us to
Yeah,
also develop these technologies locally?
yeah, that's a great question, Michael. So one, I can list them. Number one, which normally comes on top of everything, policy. Policy here, it simply means the way we had designed our policy on all our mining was for us to ship them as raw material. So there is nothing in Africa which exists beneficiation. It's called beneficiation. You can see right now is when some few countries are starting to do it. So our focus was mainly to mine. Of course, they are going to be foreign company mine, and then they are doing processing in their own country. So that was the number one. That was the biggest issue. Policy. So that policy has to change. If that policy does not change, we will go nowhere. We will continue being the raw material provider. And also the way the system is set up with this Western country, they prefer us to be a raw material supplier because it's much cheaper for them to get it that way. So I normally joke around in terms of graphite. I normally give this good example with a friend of mine in graphite. He's from a country they have graphite, but I won't mention it. So I was joking the other day with him and telling him, how much do you think we buy graphite from your country? He's like, yeah, I don't know, maybe. So most of the time, we will buy graphite from them for say something like maybe, what? Well, maybe 2,000 or maybe 1,000 per ton if they are lucky. And then we get that graphite into the US. We do some few bunch of stuff on it. make a block out of it. And then at the end of the day, that 2,000 graphite per ton which we bought from them, we turn it into products. And then those products, by the end of the day, when everything's said and done, we end up selling it for something like 200,000 USD.
Yeah.
So the markup, so we've made, if you remove all the processing, we've made almost 150,000 tons. I mean, times whatever they sold us the stuff to. So it's the people who do the processing are the guys who make the money, not the person who is mining. It's the same, for example, it's the same joke which normally goes around in if you see any area where you have a lot of artisanal mining, the person who is making the money, he's the guy who is selling the shovel and all this other stuff, not the miners. So it's the same concept. So policy has to change. If you don't change the policy, we'll go nowhere. And then once they change the policy, African country, they have to make a deliberate effort of developing capacity. Because if you do not have capacity, again, you cannot do anything. So capacity here simply means, resources, train people on how to run some of this stuff. Get in your hands with some of these equipment. Because even when you look at the Chinese, that's how they became very good. They just learned, they were sending people into the US and all this other stuff, and then they were just learning as much as possible. So that's what we need to do. Policy, capacity. And then the capacity has to be built by African government. Forget about this stupid idea from some African government whereby they normally it's so interesting. They normally let the Europeans or the US company to pay for their capacity. I want to exploit you. Why will I train you to be better at it?
Good question.
Why will I do that one? So that one, they normally do it. And that's why, for example, you will see, they will promise that they are going to do capacity building for you, but they will just be sending that thing in trickle amount. So they want you to be hooked so that you will never ever develop that capacity. So that capacity has to be built by specific African government by themselves. Don't rely on the Europeans. They are not going to do anything, or rather the US for that matter.
Oh, thank you so much. I see that our second speaker has joined, and thank you so much, Deborah, for joining. Our audience, if you can stay with us for a while Ms. Deborah gives her presentation. Dr. Peter, you can also stay at towards the end for any
Thank you
questions.
so much. I think I have something coming in the next 4 minutes. So I'll
All
drop out.
right. But thank you so much
I
for
really
joining.
appreciate you. And then for the guys if anybody wants to reach out to me, I think you have my information, you have my LinkedIn
Yes.
information. They can always reach out to me. If you want to,
Yes.
if you want to build a battery storage in Africa, reach out to us. We'll tell you. We can give you advice on how to go about it.
Oh, thank you so much. I'll share his details to everyone that has registered for this call. So I'll go ahead
Thank
to
you.
thank you. Thank you so much.
Bye.
Have a great day. Bye. I'll be introducing our second speaker. Please, audience, please stay with us because this is going to be another exceptional section. I will tell you a little bit about her, and then she's going to go on and make her own presentation. So it's my pleasure to introduce Deborah Fadei, founder Vector. She's an accomplished sustainability leader. I've followed her for close to 6 years now. She doesn't know, but I've been on her page reading up a lot of things about her. So I'm so happy and privileged that she is joining us here today. And she once served as sustainability manager at the Aerospace Technology Institute in London. And in that role, she developed and implemented environmental strategies to enhance energy efficiency and promote sustainable practices in the aerospace sector. Um, her career has spanned multiple regions and sectors. Once she was Chief Sustainability Officer at Montana recycling, and she led environmental policy development, managed energy projects, and communicated sustainability goals across diverse stakeholder groups. Deborah's career reflects a strong commitment to sustainable development, combining strategic planning, technical expertise, and collaborative leadership. Her work continues to shape innovative energy solutions and sustainable practices across the globe. You can follow Deborah on LinkedIn and you would see that she has an incredible track record of expertise in the energy sector and the sustainability space. But I would let her make her presentation now. Thank you so much, Deborah, for joining us. Yes, over to you. You're muted.
Hi everyone. Sorry, I was just trying to, get lunch. Today has been really, really busy for me. I know it's the weekend, but yeah, just pretty much trying
Thank
to.
you so much for making the time for us.
Yeah. Thank you so much to everyone for joining today. I see my friend Michael Asare on the call. Thank you, Shalom, for organizing this as well. Like, in as much as we have, several able African youths doing fantastic work in their different fields, it's very important that we have conversations like this to kind of like, hone and share expertise on what is relevant and what we could essentially leverage on to build to help deliver the bottom line. I will keep it very short and succinct. I'm hoping I'm able to do it in 5 minutes and then possibly 5 minutes for questions, and then we can round up because I reckon we've been on the call for a bit. So to the question of energy storage, grids, and the future of clean energy. I was at the Future of Energy Summit, which held between IEA, International Energy Agency, and the UK government. So there's a lot currently going on in this space. The benefits of those that do not know what energy storage and grid scale storage is, I'll share a bit of what that is. So I like to do it simple. So I know that we all know what the solar panel is, right? But obviously it makes lots of electricity during the day, but then there's an intermittency problem. So that's where storage comes in. It's like, having to save leftovers from lunch, right? So not just think about one solar panel, think about entire communities, think about entire countries, right? How do we then solve that intermittency? And I guess that's where energy storage comes in, right? So with the storage, what we currently have are huge batteries, water reservoir could be a storage. We could also have hydrogen as a storage, ammonia as a storage, because when the sun is shining and the wind is blowing during the day, you use that advantage to produce hydrogen, or you produce ammonia, and then you essentially, store it, and then you can leverage ammonia, which has a much more developed infrastructure compared to hydrogen, can transport ammonia to a place, another place, to kind of like use it for different initiatives. But I guess that's sort of giant balancing act to make sure that the lights stay on even when nature doesn't cooperate, or we get to use electricity or have access to energy even when nature is not I mean, the sun doesn't shine at night, or the wind doesn't exactly blow that much at certain times of throughout the course of the day. So all of these things are very important when you talk about ensuring grid flexibility, well, energy flexibility in that sense. So as I mentioned, the most globally relatable storage is pumped hydro. So basically moving water in uphill, downhill, letting it flow back, to generate electricity. Water is, I feel like, one of the biggest storage. Lithium batteries, obviously for solar, right? Very important, and the scale is growing super fast. There is what we are now looking at is called long duration energy storage, and we know that we need, I think, about 20 gigawatts or something. I can't quite remember the number to be able to our um fulfill net zero in different terms, right? So in terms of policy and technologies, we are also seeing governments and tech companies, well, private companies taking the lead as well. So in the US, well, prior to Trump, because we don't know what Trump is going to still do with this particular policy I'm going to talk about. But I think the IRA, which is the Inflation Reduction Act, was a game changer because one of the things that it did was to encourage clean energy deployment. And in Europe too, we've seen the Repower EU, which is used to turbocharge clean energy deployment as well. China has done it best in the way that it was unthinkable, because they looked at the clean energy landscape, right, and they developed their industrial strategy policies to suit and basically take advantage of the clean energy space. And as you can see, where you're able to if you're able to amass energy independence, or amass energy power, you also become a world power. But that's a discussion for another day. So technology wise, there is the water as a storage, there are big batteries, there are also flow batteries too as well. I think I did some flow battery work during uni. I think very cool. So that's also development. I think the difference between all of this sort of batteries in quotes, technology wise, is the energy density. How much of energy can it store, and will it store it in a way that is not bulky. Like, you don't have to install lots of batteries to be able to harness 1 megawatt hour, for example. So those are kind of like the considerations. Like I mentioned, so hydrogen is also one. To the question that Shalom shared with me, really, she talked about how we could reach 1,500 gigawatts, right? And I think that was a decision at COP29, where basically world leaders agreed to build 1,500 gigawatts of storage, right? So let me contextualize what 1,500 gigawatts is. It's like, imagine the world biggest hydro dams, right? You have like 15 of it, because one is like what 150, one is like 1.5 or so gigawatts, right? So imagine it being in 15 places, so to speak. But I guess the conversation for me, being a policy tech person, I work in sustainability, energy and sustainability. So we have to look at the entire micro and macro, not just for aerospace, but also for enabling sectors, basically the intermittence and the interdependencies, right? And I think what I've seen so far on how sectors have been able to scale to meet net zero is the fact that they cut the red tape, right? They speed up permits, they build faster, they fail faster, they build faster. They invest more into research and development, particularly with the UK. The UK is investing so much in research and development, to further moonshot technologies, as they call it. In aerospace, for example, we're working on hydrogen-powered flights. We're working on SAF powered flights too as well. Like, instead of using 20% or 30% or 5%, we're looking at 100%. self-powered flights, and how are we able to we design the landscape to allow for that. Another consideration is that with hydrogen-powered flights, now the conventional flights, the aircraft, right, the wings store the fuel, but with hydrogen-powered flights, that will have to change. Obviously, you need research and development to be able to come up with better, smarter aircrafts. So you need to invest more. So I think pretty much building faster, investing more is how we actually get to that 1,500 gigawatts. And I know that it's a huge job because it's a matter of skill and speed. But I also think it gives me two perspectives to think from. So one is research and the second is entrepreneurship. I think research and entrepreneurship is highly linked. So if you're, say an if you're a researcher or an entrepreneur on this call, I think this is the time that you start to think of how you can leverage new thinking, how you can, take advantage of this opportunity to invent, to create, and to work with different stakeholders to ensure that, basically you are able to supercharge this opportunity, right? At the IEA UK Energy Summit, I was told to speak, right, about what the role that, young people, young professionals can essentially play. And I think the beauty about it is that, in as much as the old folks have so much experience, right, because age is experience, right? We as young professionals, we as that career space for our generation, we have to develop our skills in a way that leverages an interdisciplinary approach, right? Because if you're going to solve this challenge of scaling 1,500 gigawatts, right? You're not just considering the technology, you're considering what it means for what it would mean in terms of the social perspective, what it would mean in terms of the financial, creating business cases for it, right? So it's not just like a technical fix when you're thinking of how to, pretty much shape what the future of energy would look like, or how we can achieve 1,500 gigawatts of energy storage. But more importantly is the fact that there are huge opportunities. Yes, we have half of the world's population being under 30, right? Which means that there's a lot of youths that would need jobs. And I think just being within the clean energy sector guarantees that, just being able to create solutions for the clean energy transition guarantees that. I mean, the energy storage bit is just one bit of it, right? So I think for me, when you're thinking of how to essentially solve for this, understand that there is a need to build faster, right? So how do you create innovations that allow for time to be crunched? What are you thinking about when it comes to research? What motives are you applying? And the beauty about it is that I would say take for example, Michael grew up in Ghana, right? And access to electricity, isn't is well, there's still some places in Ghana that do not have access to electricity. So how do we take the lived experiences of Michael, for example, and build solutions that can be localized? So when you're doing research, whatever research projects you're working on, think of how you can actively use it to solve for the clean energy transition. Not necessarily towards, obviously, the energy storage piece is just one part, right? There is issues with cybersecurity, leveraging AI to achieve energy transition. There's supply chain issues, there's critical minerals, all of those bits, just having to look at research and look at how, you can leverage research and entrepreneurship, because I feel like there is no entrepreneurship without research, right? You have to innovate for you to be able to play within the entrepreneurial space. So just having to leverage these things to build faster is very important. And then obviously with entrepreneurship, public-private partnerships, investment comes in. And then with investment from different organizations, different entities, just funding clean energy transition, particularly through research, R&T, research and technology would help. I think I will stop here for now. And if there are any questions, I can take them and then we can move the conversation forward.
Yes, thank you so much. And I would open the floor for questions. So if you have a question for Deborah, please raise your hand or you can drop them in the chat box. I see Michael already, but you mentioned a lot of interesting things. You talked about research, you talked about entrepreneurship, you talked about AI, the supply chain issues. In fact, there are a lot of places that I have questions, but I would just want to start with where I'm currently doing my research in. So I'm doing building mathematical models for SAF optimization. So a lot on decarbonization fuels and how to optimize and get the most cost effective and the most sustainable options. And I feel that every of this sector, they are intertwined. But the last part that you mentioned about localizing the solutions of our research is the part I wanted to start off the conversations on. If, for example, I mean, I wouldn't be able to be empowered to do this kind of research if I was not in the US, because sustainable aviation fuels, I feel the transformation on that is really stemming from, developed countries and not, developing countries like Africa. Those kind of research are usually far-fetched. So how do we bridge these capacity building gaps, knowing fully well that the countries we come from are very far from the conversations that are going on, especially the transformations that are going on. AI is already here, and a lot of new solutions are being built. So how do we bridge that gap between driving what global solutions or what the developed countries have really worked on and they are successful? How do we now localize them, for countries that are still developing, for example, Africa? I don't know if that question was clear.
You hear me?
Yes,
I think
we
the
hear you
last
now.
of the question. I
Okay.
didn't hear.
So how do we bridge that capacity gap, especially because the main research that are transforming the world in developed countries are high end? Like you mentioned the thing about a SAF, that sustainable aviation fuels, and I was just talking about my research. And the other part where you mentioned about localizing solutions. So it's really now making me curious to how can I transform the knowledge that I'm getting from this place? Because now in the US, how do we transform those solutions and drive it down to Africa where, the solutions are still needed as well?
Yes. So I think obviously I've always asked this question, right? The why is the global north moving faster than the global south?
Too fast.
Yes. And I think essentially, I think there are no enablers in Africa for us to be able to do certain things. And, take for example, with you working on SAF research, it's going to definitely benefit Africa, because Africa is such a great place to make hydrogen, right? Take for example, Namibia is so I think it's about focusing on, African nations that are moving ahead of the curve. So with Namibia is focusing on hydrogen, right? There is not enough biosaf in the world that can meet our
The demand.
we need to rely on e-fuels like eSAF, PTL SAF, which needs hydrogen, right? Which needs hydrogen, which needs carbon capture. So when you take this initiatives, right? When you take up this kind of initiatives, we just remember at the back of your head, and I'm saying this from a place of love, you are a global candidate. You're a global individual, right? Africa would essentially catch up, and when Africa catches up, you'll be there, right there to help them with their transition. So if it's not working at the moment, or if you're not able to get access to the enablers that would help you develop solutions within your own country or within Africa, it's fine. Continue to develop it where you are at, right? And then with the premise that, you know, when it gets to Africa's turn, you're then able to, you know, implement for Africa because you have captured the scalability and localization in your model. You know, we have lived experiences, we have so much power, we do not understand. We build differently, right? We build differently because, you know, we've got context.
Yeah.
What energy poverty is. So we are going to work with that reality, you know. We'll consider affordability for one, we'll consider what will people do if they have to sit beside a hydrogen gasket or something. How will people feel about that? The public perception of it. We'll consider all of that when we are trying to design solutions, which many many people that don't look like us will not be able to. Yeah.
Thank you so much for that. I'll give it to Michael.
Thank you very much, Shalom, and thank you to Deborah for such a brilliant presentation. And I've really learned a lot from your presentation. It was so great. Yes, I wanted to ask this question. I think you spoke more about research. So, for example, I know in global north countries, there are a lot of research in battery storage, green hydrogen, sustainable aviation fuels, and what have you. But in this context of the global south, where even people don't have access to electricity in the first place, then even talking about affordability, and even those who even have access to electricity are facing significant challenges with reliability. So even attracting these investments of maybe tech companies to even come and establish these manufacturing industries in Africa or in global south countries is a challenge. So in this context, what do you think our focus should be on? Because some of these technologies, for it to even, you need stabilized grids, like modernized grids to integrate all these variable and flexible mechanisms like the battery storage and what we call the renewable. So if we've not really tackled the basics of even getting good grades, getting reliable access to electricity, how then do we try and even bring these new innovations? So my question is, what should we do now? What should be the main focus of global um, South countries? Because some of these technologies, for example, these smart grids, battery storage, and all those things, if you currently, our challenge is we have different challenges now
Yes,
that we
yeah.
need to really focus on. So if you are bringing these new things, it's and that's the mistake I think most of our politicians do. Sometimes they talk about things. Oh, we are trying to explore smart grid, EVs. We will not solve the basic. We are just copying from them without really getting our first things done. So this is what I want to ask. Like, what should we do? What should be our focus now?
I think you should innovate based on what your challenges are, right? I think it's as simple as that. Innovate based on what your challenges are. If you take, for example, with solar mini grids, for example, solar mini grids will never work for rural and marginalized communities because number one, they cannot afford it, right? They cannot afford it. They have the willingness to pay, but the capacity is missing, right? So there's something that I think the C4L calls the tiers of electricity. So obviously, solar lamps, honestly, I think we've moved past it, particularly for rural marginalized communities where there are productive use cases there. You know, there is a agriculture, you know, having to turn say, for example, corn into pap or something, right? Mini grids might not work there, but microgrids would work, or DC appliances that, you know, can power these kind of like productive use cases, right? And as they better their, what's it called, the better their finances, then you can move them up the ladder, right? And I think when we are innovating, when we allow the North to innovate for us, we end up with climate colonialism, right? Take for example, they're asking the global South to cut their carbon budget, and I'm like, the global South hasn't exactly achieved industrialization. For us to be able to achieve industrialization, we need lots of power. So it's either we rely on coal or fossil fuel, oil and gas to do that, or you give us the finance needed to deploy megawatts and gigawatts of solar and wind, right? And how do we do that? Raise the carbon pricing, raise the price of carbon high so that there is a statutory what's it called? Oh, it says I'm raising my hand, I'm not. So there's a statutory price, right? Such that when the global South wants to implement solar projects that actively achieve industrialization, then they get paid for it, right? So it's about that trade. So if we have like that, and that's one innovation. So if we have innovation that actually spurs us to build localized solutions for Africa, then we move faster as opposed to just importing the solutions that the global North thinks that will work for Africa. So we need to create solutions that are made by us, for us, by Africa, for Africa, by Africans, for Africa.
Africans.
Yes, exactly. So I think it's just about innovating according to, we can take their technical know-how, we can take the technical know-how, right? But obviously you need to have understanding of what technical know-how is to be able to implement for Africa. I guess that's the point. Look around, look what's happening within your environment. Obviously, solar PV is not an innovation anymore per se, you get, but having to deploy, maybe increase the efficiency or how you arrange the panels or what you do, there has to be something that speaks to the challenges of your community that you imbibe within the structure or the structure of your solution to enable them enjoy it better. It could even be as straightforward as the business model affordability, having to drive the affordability, who pays for what. So with Reese Africa, one of so I have a non-profit. We take over the capex, so the capital expenditure, and then we create models for them to run the operational expenditure themselves, right? So they just pay like a little something to ensure that the system is in operation and is being maintained. So yeah, like I said, innovation according to the challenges within or the nuances within the said community or environment is very important.
Okay, thank you very much. But I also think that maybe, what about research? Well, it's like most of these research works, even that is being done in global south, are funded, or even most of our, like I read about an article that was saying that most research or initiatives are done by global, not for global south. So if somebody's doing your research for you, how will you? We don't have like dedicated
It's okay.
farms and
Those
laboratories to even
spaces, that's what
calculate.
I would say. Get into those spaces that you get into them. We are Africans on this call, right? What
Yeah.
are the projects that we are working on? What kind of Shalom just said she's working on SAF, right? She's going to be one of the biggest SAF experts in the next coming years, right? And when Nigeria calls for Shalom, oh, we need someone that is an expert in SAF. Shalom's name is going to come up, right? And Shalom will be able to develop solutions for Nigeria, for Africa, based on the research. So fine, I know that it's easy to say, like, we'll get into those spaces, right? But I think even if, having to play the long game in itself, Michael, like, they might say, okay, you are doing this, you're doing this because we funded you to do this. Try and find ways that, okay, this innovation that I'm implementing for them, is there a way that it can be applied to Nigeria, to Africa, right? Is there a way that, in as much as, is applied to Germany, can it also be applied to Africa if we look at it, Ghana, if we look at it, right? And the truth is that when your solution has a global context, right, it gives it more credibility. So, and I guess that's where innovation lies, right? Having to ask that question really to say, okay, this thing that I'm building, can it also be applied to take, for example, with what we are building, we are building at Aerospace Technology Institute, hydrogen-powered aircrafts, right? Obviously, at some point in time, whether 2100, Africa will fly hydrogen-powered aircraft. It could be the one that has already been used. You know how they used to do it now, that they would ship
to us.
yes. It could be the ones that they've already used, but we will still use it. They are building with the mindset that, okay, the world will need hydrogen-powered aircrafts. It's not just them, what's it called? And that's why they employ people like us that look like us, right? Do you get?
You
It's
have
not,
a point.
do you get? So because they know that we will bring a diverse kind of to it, not because they are trying to, but they know that, this skin has something that they do not have, right? We might not be in plenty because we are very underrepresented, right? But they'll put us in like key positions, key places. They know that, so that whatever they are building can have a global effect, right? So I think that's it's a long game, because I could as well be doing this for Nigeria, but Nigeria is not ready yet. She gets, but when Nigeria is ready, I could play a role in that, because I've done it for another country, right? So for every time I develop solutions, I'm thinking, how is this applicable to Africa too as well? Yeah.
That's amazing. And I don't want us to take further again, but I think one thing that each speaker has talked about, both from the first speaker to Deborah now, is it's about research, and we owning the space as Africans, going into the research in the space so that we can innovate when the time comes for Africa and generally the global south to take actions on the energy transition. And one of the things that was echoed was the fact that Africans should develop African solutions. And I think that's one key takeaway from me from this section. So thank you so much everyone for joining the call. I don't know if people are still available to turn on their cameras for a final picture, but we would really love a closing picture now if we are still available. Mr. Sambo, how is France? Jonathan, Michael, if you're in a comfortable place, we'll just want to take a final picture at the end. Hi, Michael. Nice to see you. Shadrach, if you're in a comfortable place, you can turn on your camera so that we can just take a final picture. But it's fine. So we'll take the picture now. I'll just count to three. 1, 2, 3. Thank you so much. Thank you so much, everyone, for joining us in our April edition. We'll send details for the next edition in May. And in May, we'll be talking about artificial intelligence and energy efficiency. So do well to connect with us. So thank you so much, Miss Deborah. Thank you so much for joining us. I really appreciate it. And everyone, follow her on LinkedIn. She does a podcast. She also shares a lot of insights on sustainability and energy. So do well to subscribe to her newsletters, follow her company. She shares a lot of advices there. So we'll be ending the section here. Thank you once again.
Thank you so much.
Yes. Have a great day.
Mm.
All right, bye.
Bye.
Bye, Michael. Thank you. Let's join again next month. Next month. Thank you.